So this is the beginning of chapter 3, and it's called Parallel Lines and Planes. This builds on some of the material that you did in middle school with parallel lines. So we're going to be talking about a few different vocabulary words related to this picture. First one is going to be parallel lines. Parallel lines are two lines that do not intersect and are coplanar. So if you look at this particular picture, I have two planes, plane T and plane U. Both lines M and N are sitting on this same plane. So they do not cross each other, but they share the same plane. And symbolically, it's M parallel to N. M is parallel to N. Notice I've used lowercase letters, and I've got the parallel symbol in between. This is a new vocabulary word, skew. Skew lines are two lines that do not intersect and are not coplanar. So an example of this in a classroom is going to be, for example, this front portion of this floor meeting the wall. That creates a line. Now, if you look in the back corner of the room, the vertical line that's created with the two intersection of those two walls, these two lines will never intersect and they're not in the same plane. Those are known as skew lines. Here's an example of skew lines in the picture. Lines M and K are skewed. So line K here looks like it's intersecting both of the planes, but line M is in plane T and it will never touch line K. It will never touch it. So they'll never touch it, they're not parallel, so they're known as skew lines. For skew now, just the word skew. Just like lines are parallel sometimes, so can planes. Planes can be parallel as well. And that is two planes that do not intersect. In these particular pictures, to show symbolically that you're not intersecting the planes, I'm going to use the capital letters that represent plane T and plane U. So this shows me plane T parallel to plane U. You'll notice with the lines, it was lowercase letters. You can also name them by new points on the line, but in this particular case, we don't have any of those values. The last thing that I want you to write down here, a line and a plane can also be parallel if they do not intersect. So for example, in this picture, line M is also parallel to line U because their planes happen to be parallel as well. So this is a way to show a line and a plane being parallel. Lowercase m is the line M, capital U for the plane U. So for this picture on the far right-hand side of your paper, I want you to name a pair of parallel lines and name a pair of perpendicular lines. Think back into middle school. Are there symbols on your lines that show they're parallel? Talk to your neighbor. Okay, for the first scenario, you have AB parallel to CD, and make sure you have the line bars over the top, indicating you have lines and not segments. And in the picture, you can tell they're parallel because they've indicated with an extra set of arrows on the lines that they're parallel. And for the second set, we have the perpendicular because of the fact that you have the marking for a right angle inside of the picture. Okay, a couple of brief review vocabulary again. Intersecting lines are lines that intersect at one point. Parallels are coplanar but not intersecting. And then here's another example of a set of skew lines that are not intersecting. I have plane A and plane B, and you can see I have a line in each of these, but in this case, they're not parallel to each other, so even just lying in different planes, one above the other, but not being parallel, does create a skew scenario. All right. With your partners, I want you to go ahead and answer the 4 questions that are here. They do say in all cases which line, so all of your answers should have line bars over the top of them. Even though these are segments visually, assume that there are lines that are extending out infinitely. So answer the 4 questions, then I'll take volunteers to come up and complete those. So correct the answers here, A, B for the first one, AH and AG, AD, and then plane CBA. I think it's CBA. Is that a B? So let's do
Yes.
CBA. Okay, any questions on these four? Noah? Okay, so this next picture has to do with something you did talk about when you were in middle school. So I have two lines here, L1 and L2. They're intersected by a third line, creating 8 different angles. The line of intersection is called a transversal. What I'm going to have you do with your groups right now is talk about things that you do remember. Do you remember what a corresponding angle is? Do you remember what a same-side interior is? Do you remember what an alternate interior is? What I'm going to do is give you a hint on each one, and you're going to take a few minutes and see if you know which ones fit which vocabulary. So for this first one, I am going to tell you a corresponding pair. Angle 2 and angle 6 are corresponding. One set of same-side interior is angle 3 and angle 5. Another set of alternate interior is angle 3 and angle 6. Take a few minutes with your partners and see if you can complete all 3. There's other angles here that fit that. So in this particular picture, there's 4 sets of corresponding angles, 2 sets of same-side interior, and 2 sets of alternate interior. Let's go ahead and do the vocabulary for those. So you're going to turn the page. So let's start with corresponding. On your paper, I'm giving you a physical example of what you see that are going to be corresponding angles and the vocabulary that goes with it. So in this first example, angle 2 and 6 are corresponding. They're angles that have corresponding positions. When I say corresponding positions, here's what I mean. I have the 2 lines that are almost horizontal to each other. Angle 2 is in the upper right-hand side of the line with its transversal. Angle 6 is also in the upper right-hand corner with its respective line and transversal. So same location, just on a different line, but they have the same parallel. So they're both have the same transversal. So they're both to the right of the transversal and above the line that they're representing. The next one is the alternate interior angles. Interior meaning inside of the lines. Alternate means opposite side of the transversals. So angles that lie inside the 2 lines and on opposite sides of the transversal. Now the next example is something that we didn't talk about in the sample that you had. Alternate exterior. Alternate means opposite sides of the transversal, but exterior means outside. In other words, outside of the 2 respective lines. Angles that lie outside of the 2 lines and on opposite sides of the transversal. For this last vocabulary word, you have same angles where they're on the same side of the transversal, but they're between the 2 lines. That would be the same side interior that we did from the sample. Another way to word it is consecutive interior angles. So it's angles that lie inside the 2 lines and on the same side of the transversal. I usually say same side interior. Some people say consecutive interior. Now this particular picture is laid out a little differently. This time you'll see the 2 lines in respect to the problem almost vertical with another line that's acting as the transversal. You still have 8 angles though. With your partners, find all the pairs of corresponding alternate interiors, alternate exteriors, and consecutive interiors. Alright, I think these look pretty good. I don't see any mistakes that I'm noticing offhand. Any questions on any of the pairings here? Alright, so now we're going to switch gears and it's become a little bit more complicated. So in this particular picture, you're going to see 4 lines rather than 3. So for example, if I take the 2 lines that are almost horizontal, they have 2 transversals. If I look at this first transversal, the 5, 6, 7, 8 have something to do with the 13, 14, 15, 16. Additionally, there's another transversal further to the left, so 1, 2, 3, 4 have something to do with the 9, 10, 11, 12. I also have the opposite scenario. If I take the 2 that are almost vertical and treat the upper almost horizontal as its transversal, 1, 2, 3, and 4 have something to do with 5, 6, 7, 8. If I take the bottom transversal, 9, 10, 11, and 12 have something to do with 13, 14, 15, and 16. So what you have to do is take the two angles I give you, angle 1 and angle 9, and define what type of angle they are. So 1 and 9 are located between, well, they're actually related to these two that are almost horizontal with this transversal. So what would 1 and 9 be in relationship to each other? They are corresponding, so that would be your answer for that first one. Now what I want you to do is give the vocabulary for all of those, all 6 of those, and then down here I want you to go ahead and answer always, sometimes, or never. So the answers to the top portion, SS would represent same side interior, or you could also say, what's the other one, consecutive interior angles as well. Let's look at the other ones. If two lines are parallel, they will?
Never.
Good, never intersect. Next one, if one line is skewed to another, they are never coplanar. If two lines intersect, they are sometimes perpendicular. And the last one, if two lines are coplanar, they are sometimes parallel. Final theorem for the day. When two parallel planes are cut by a third plane, the lines of intersection are parallel. So in this case, line AB is parallel to line CD.
Oh, it's actually not doing